Hi everyone, my name is Martin Linksfeld and I am Master Chef in FoggyKitchen.com. Some time ago, I have published few recordings about OCI ATP features, including video about ATP clones from backup or directly from ATP instance. Today, I would like to continue this topic. But this time, I will talk about new feature called Refreshable Clone. From my perspective, it is a significant adjustment to already existing features. You can create a copy of your database which can be periodically refreshed for any analytical purposes. It is a question of one form and one button to move your database clone to appropriate state and time. In this video, I will show the example how to do it in a practice. And as always, I will use Terraform to automate it. First, let's roll to the topology diagram just to understand the configuration. Okay, here's our topology diagram. Here we have ATP instance, let's say the original one, and yet another one called Refreshable Clone created automatically by our cloud automation. Right? So we are expecting to have a clone which can be refreshed from the original instance. Then we have two web servers, one in blue, web server 1, and second one in green, also available in the same network. But the role of these web servers will be slightly different. It will not be a cluster or something exposed in a form of load balanced traffic. No, the first web server will be for the purpose of exposing the content of original ATP instance, right, to our web browser. Then we will have a refresh from our original ATP instance to our clone, and then the content of the refreshable clone will be exposed through web server 2, right? So that will be a proof that refresh will take place. I am now on my Terraform server, and first thing I will do is a clone of my repo. I will go directly to this repository. Let me check the branches. So as you can see, we have a lot of remote branches here, including this one, refresh clone. And we can see it here as well, right? And this branch is well prepared for our refreshable clone, right? So let me do another thing, which is fetch all, git pull all, and now I will check out to this refresh clone, right? And now I have proper code in place from this upstream. Now I will run Terraform init, and I will run Terraform plan just to see what is planned here. $33 resources to be added. It will include ATP original instance and refreshable clone, as well as two web servers, right? Let me scroll up a little bit just to catch servers. Server 2, web server 2, and web server 1. Okay, so let me run Terraform apply, and we will wait for the outcome of this automation. I will pause for a moment. Okay, our automation is still in the middle, but as you can see, we have finished the original ATP instance provisioning, and now we have refreshable clone in the middle, right, under provisioning. So we can go here and we can see in work request that the process of creating is, in the middle, 10% so far. And yeah, let's return back here. In our original ATP instance, we can see refreshable clones, and this one is still under provisioning, right? One thing which is very important is a version. It should be 19C. It will not work in 18C. Okay, so now I will again pause and we'll wait until the end of the provisioning. Okay, looks like the Terraform apply is finished. So our refreshable clone is has been successfully created. Now we can go directly to first server just to verify if we have 3 records from ATP from Foggy Kitchen table, and we can do the same for a second web server where this initial set of records has been moved, right? And now it is a moment where we can try to update the original database, right, with new records. So let me log in directly to our first web server. Okay, so let me log in into the first server. I will switch the user to root and I will go to /tmp directory. And here we have shell wrapper, which will show us the current content of ATP table, right? Foggy Kitchen table. The same as you can see in a web browser, right? And here we have a script which is updating database with 3 additional records. So now the query will give us more records, record 4, 5, and 6, and we will refresh the first web server. So in our ATP original instance, now we have 6 records. What about the clone? Still 3, which means we need to now ignite the refresh. Okay, right now we have 12:04 GMT, so we have done it a few minutes ago. So let's move to our refresh clone and we will choose today and right 12 UTC. Hopefully it will update our database, right? And now ATP clone is updating, right? So we have this refresh. We have work request, which is accepted, and we need to wait, let's say, some time, and we need to wait for green color, right, of this work request. So I'll pause for a moment. Looks like the manual refresh has been done, so work request is finished, succeeded. Okay, so let's refresh second server, and unfortunately, as you can see, no data has been refreshed, so we have still 3 records. What does it mean? It means our changes, our update has been introduced after 12, but not before 12:40. 30, sorry. And which means we need to wait a few minutes more, right? A few minutes more to just have all of the data sent refreshed to the clone, right? So we'll choose this one, but we need to wait until this moment in time. So I will pause for a moment and we'll return when this date will be available for us. Okay, looks like we have reached the refresh point timestamp. So let us do it again. And now we can refresh it again with hope that now all of the data, 3 records, will be added to our clone. So again, because it takes some time, I will pause for a moment. Okay, second manual refresh is finished, right? So let us check the second web server. Okay, so it looks like this time data has been moved from ATP original one to the clone, and all of the free records are now included. So it's an ultimate proof that this functionality works fine. And that is all for today. Thank you and see you soon.